Afternoon, everyone. Thanks very much for joining today. I'm joined by Pat Kiernan, who's the Vice Chair of our Energy Action and Climate um, Action Division within Engineers Ireland. My name's Siobhan McHugh. I'm the Chair of the division as well. So we're really pleased to offer another lunchtime seminar. Today we're joined by Brendan Murphy here, who is our speaker today. So looking forward to a really interesting discussion. We will have questions that you can put into the seminar chat as well, and we'll put those to Brendan when he's done his presentation. I'll give you a brief overview, just an opening up on our speaker today. So thank you very much, Brendan, for joining us. Brendan Murphy is a chartered engineer. He's worked with PM Group for 30 years, so initially as mechanical department manager, then as project manager, and finally as projects department manager for the Dublin office. He's worked on multidiscipline design projects primarily for pharmaceutical, fine chemicals and food processing industries. And this has included consideration of energy systems and their efficiencies. More recently, also included consideration of minimising environmental impacts was a major part of the design process as well. So we're delighted to have you today, Brendan, and to have you speak on this topic. I'll let you maybe open up and give us a brief introduction to yourself and to the topic as well.
Okay, thank you, Siobhan, and thank you everybody for attending the presentation. I hope that what I have to say makes sense. If not, I'm happy to take questions at the end of the session, as Siobhan said. Alternatively, I can do it offline, and Sinead will provide you with my phone number and email address in that regard. Up to a few years ago, I took the same view as many did, in that I assumed that the actions we were taking in tackling climate change were going to be effective. However, I retired a few years ago and then began to use my time to look in more detail at the real situation. Having analysed the data, I realised that much of what is being done has minimal effect. In some cases, it has a negative effect. I came to the conclusion that the only real solution was to switch totally to renewables, rather than to try cut back on fossil fuels or increase efficiency. We have an average time, and we as individuals are incapable of dealing with the situation. We can do some small things, but it must be handled at government level for the bigger actions. For the record, the figures that I'm using in the presentation are based on 2024 data, which is the latest full year figures available to me. So Siobhan, if you could switch off my video, please. So first of all, I want to give a bit of history and context to the presentation. I'm only considering energy. I'm not dealing with agriculture emissions, although there are misunderstandings there too. Nor am I dealing with manufacturing byproducts, for example, CO2 emitted from cement manufacture. First of all, I want to ask the question, what do we mean by energy? Many equate energy with electrical energy. However, this only accounts for about 30% of total energy usage. We have been aware of the climate issue for decades. The risk was first identified by scientists in the 19th century, but it was treated as an academic issue. Serious discussion only began in the 1970s. That's over 50 years ago. Since then, we have been concentrating on reduction in fossil fuels and improving efficiency rather than replacing them. There has been little progress on renewables other than for electricity generation. We have probably reached the limit of what is achievable there. We have a lot of tokenism and virtual signaling. For instance, many go around switching off lights in the house, thinking this is good, which of course it is. However, a modern 10 LED light can run for 100 hours. That's more than 4 days using just 1 kilowatt hour of electricity. Compare this with a 4 kilowatt oven. This will consume 1 kilowatt hour in the first 15 minutes of operation. We see electrical vehicles commercial vehicles displaying the sign that they are zero emissions. This is not the case, which I'll cover later in the presentation. Many companies in their documentation and websites claim that they are eco-friendly without being specific about exactly what they mean. Alternatively, they state that their operations are sustainable, again, without being specific. There are many other examples of virtual signaling and tokenism. Okay. So this slide shows the current status in terms of our energy usage. In Ireland, as you can see on the left-hand side, we are currently using 78% fossil fuels and just 22% renewables in terms of our total energy. Worldwide, there's an 81% use of fossil fuels with, just get that out of the way, with 15% renewables and 4% nuclear. So that's the big issue, this fossil fuel use here. Now we look, as I mentioned, we've been looking at this seriously for the last 50 years. And I just took the last 60 years as for this graph. So as you can see, in Ireland, there was more or less a continuous growth in use of energy right up to about the year 2000. This is followed by a period of ups and downs, which I'll cover in the next slide. Globally, the growth was continuous right up to the present day in both overall energy use and in fossil fuels. Renewables only grew slightly in that period of time. Here we focus on the last 20 years. In Ireland, the demand peaked around about the year 2008, which was followed by a drop-off which coincided with the global financial crisis. The graph more or less plateaus after that up to the present day. There was an apparent drop in fossil fuels demand and a rise in renewables in that period of time, with an anomaly around about the year 2020 to do with the COVID pandemic. While there was an apparent slight fall off in fossil fuel use in that period, there was an increase in the amount of electrical energy imported. This does not show up on our national consumption figures, so the real figure for fossil fuels will be higher. In any event, the downward trend is only very slight, and if you extrapolate out, we'll be out decades before we'd get any significant improvement. Globally, with the exception of the blip in to do with the global financial crisis and again to do with the global pandemic, there was a continuous rise in overall energy use and in fossil fuel use. This slide deals just with electrical energy. As I mentioned, electrical energy only accounts for 30% of our total energy demand. From the pie chart, you can see that renewables account for 45% of our electrical energy, with wind accounting for a big part of that. So that wind energy accounts for about 80% of the total renewables. That's something that has to change, and we need to look at, well, it's not part of this presentation, we need to look at alternatives such as tidal and wave energy, and perhaps many process plants use aerobic digestion for getting rid of organic waste. If that was converted to anaerobic digestion and producing methane, that would be a help. Looking at the fossil fuel end, 49% is gas, but there's 3% coal and 3% oil, which I'll cover later which will be relevant to a later part of the presentation. Again, if we look at the graph, while the overall amount of energy, electrical energy, has increased slightly with some ups and downs, fossil fuels have reduced and renewables have increased. To cover actions that have currently been advocated but which have a minor effect. So let's look at home insulation upgrades. Energy used for home heating accounts for just 10% of total energy consumption. If we were to upgrade every home in the country to the recommended BE or B2 classification, that's the SEAI recommended figure, we would save about half of that, i.e. a total of 5% of total energy. There are about 2 million households in the country. All of them would have to make the decision to upgrade and to spend considerable funds doing so to achieve this 5% reduction. It would take decades to achieve this, if ever. Therefore, while good in itself, this is not going to achieve the desired result in tackling climate change. Use of private cars versus public transport. Like households heating, private car use accounts for just 10% of CO2 emissions. However, if we switch to public transport, we don't save all of this, as public transport is not CO2 emission free. If we take a double-decker bus, for example, a double-decker bus with 10 passengers on board is a break-even scenario. That is, it would use the same amount of fuel compared with a diesel car with a diesel bus and emit the same quantity of CO2 as though passengers were driving their own cars as single occupants without passengers. But what is the real scenario? I don't have figures, or I can't find figures for occupancy across all routes and times. However, if we look at the quality bus corridors in Dublin, at peak times, the occupancy is only 53%, which you would expect that to be much higher. Anecdotally, occupancy for other periods, particularly mid-morning, mid-afternoon and evenings, is considerably less than this. You have to factor in that the bus has to travel. You also have to factor in that the bus has to travel from the depot to the terminus in the morning and back to the depot in the evening without passengers. Also, at the start of the journey, it will leave the terminus with none or few passengers, gradually filling up as it progresses. When all this is considered, we could be that the average figure is at or below break-even, as mentioned above. Even if it is not, savings in emissions of CO2 will be low single-digit percentages. Similar to households, there are about 2 million private cars in the country. Even to achieve this low figure of savings, all of these owners would need to give up using their cars and switch to public transport. Because cars are ubiquitous, it is assumed that they are big users of fuel. However, much of the time they are just parked up but visible. On average, users use their car about 5% of the time. In any event, there's not going to be a widespread take-up of this option purely for the convenience of having your own car to drive. Afforestation is touted as being good for the environment, which of course it is. However, if we look at the practicalities, to mitigate fossil fuels currently used in Ireland, we would need to plant 30 million trees annually. However, absorption of CO2 will only happen gradually over the lifetime of the tree as it grows to maturity. This will take decades. For the initial tree growth, we will continue to emit CO2 to the atmosphere, but none of it will be absorbed. It is only as it matures, CO2 will be taken up. Regardless of the species of trees, it will take decades to reach maturity. Also, this will be an indefinite action. We will need to plant 30 million trees every year, right to the future. Ultimately, we will run out of land. Note that we currently are planting about 4 million trees annually. Other forms of carbon capture may provide some short-term benefits. However, all other forms of carbon capture require significant amounts of energy, which will have to be supplied by renewables. And long-term, the issue of available storage space running out will be a problem. It would be better to use these resources in providing renewables. Now I want to look at actions that have a negative effect. Pending sufficient renewables, fossil fuel versus electrical devices need to be considered. For example, heat pumps, electric vehicles, electric home heatings. Replacing fossil fuels with electrical devices assumes zero emissions resulting from this. However, we must assume that electricity is used by fossil fuel burning plants. Let me explain. First of all, we must assume that, look at the cause and effect. Let's assume that the power grid is run on an eco-friendly basis. As a side issue, it's not at the moment, it's run on a commercial basis. In that case, we maximize the use of renewables. Then as demand increases, we bring on two-stage gas generation and finally other fossil fuel plants. Note the earlier slide that you are still using 3% coal and 3% oil as sources of electricity energy. Let's assume that generating electricity is being run as per this scenario. If we then add a new load, in this case electric vehicles, fossil fuel plants generation must be used. If we are already maximizing the use of renewables, therefore, the effect of electrical loads is the need to bring on or ramp up fossil fuel generation. This results in CO2 emissions from the generation plant. This is the scenario that we must assume is in play. So, into this slide, I will look at the overall efficiency of heat pumps and electric cars. First of all, primary power plant generation is typically about 33%. The distribution, that's taking into account the losses in transmission lines, transformers, etc., is 92%. You have an 8% loss, so there's 92% efficiency, and then the actual motor driving the heat pump is 90%, and that gives you an overall efficiency of 27%. Similarly, for electric cars, the overall efficiency is 23%. In addition to the thermal efficiency, which I've covered in the last slide, you have to look at then the emissions related to the actual fuel. And here you see the emissions related to CO2 per unit of energy. And if we look at the ratio of the the CO2, first of all, in relation to natural gas, compared with hard coal, the CO2 will be 1.7 or 70% more than for natural gas. And if we look at the figure for oil versus hard coal, it's a 30% more. Now, if we look at home heating and comparing condensing boiler with the heat pump, a condensing boiler typically has an overall efficiency of about 90%. If you compare that with a condensing boiler burning oil versus electrical generation using oil, as shown earlier, the efficiency of the heat pump is 27%. We would then need to achieve a COP of, sorry, just give me 1 second. We would then need to see a COP of 3.3% to achieve a break-even situation. For those not familiar with COP, that's essentially the multiplier of input power to output energy. So if you have 1 kilowatt of input energy to your motor, you get 3.3%, 3.3 kilowatts of energy into your heating system. But if you look at the COP, this is a graph of COP depending on the various conditions, outside air temperature, inside water temperature. It's difficult to see, but it's only this bit of the graph here which achieves a figure above the 3.3%. So the chances of the chance of heat pump being effective and reducing the CO2 emissions are quite low. Here we look at the figures of efficiency and gas, or sorry, CO2 emissions relative to car usage. So if we look at the electric car, take the electric car, for instance, versus petrol and diesel, the emissions for compared with the petrol car are up 30% versus a diesel car up 70%. And if you look at versus gas to gas, it's 1. But these are the figures that we need to look at. And if you look at coal generation, actually for the charging, it's 60% higher for petrol and 20% or 120% higher for diesel. Yeah, okay. So what do we do? Switching to renewables is the only way forward, in my view. Individuals can't do it. We can do some of the small stuff, but not enough to achieve the objectives. Commercial ventures won't do it either. Companies are in business to make a profit. That is their only reason for being in existence. Providing a service or goods is only a means to that end. We can't wait for them to see a return on their investment. Governments must do it. They must take the lead in planning, putting together project teams to handle the job. They must put budgets and schedules in place. Objectives must be defined for achieving the ends. Only governments have the power and funds necessary to tackle the problem. So, next steps. Governments are always considering the next election. They must forget that. They must plan and implement well ahead of the need, i.e. provide generation plans and grid upgrades to cater for the demand. And one other thing that hasn't been considered is that there'll be a huge amount of storage as things like solar power only work during the day, so they need storage of electricity for battery storage or whatever, maybe pump storage to handle the off peak times. They must cater for increased demand. For instance, fossil fuels are used in factories, but I don't see a strategy in place to deal with industrial and commercial entities switching to renewables. Companies won't convert until renewables are available, as mentioned earlier. They are in business to make money. It must appoint task force to design, procure contracts for supply of equipment and for construction, then execute the works. These task force should mainly consist of relevant professionals, engineers, climate scientists, architects. Politicians may be involved, but their influence should be limited because they're always looking to the next election. Sorry, I lost my. Yeah. Multi-budget finance must be approved. This is to ensure that finance is available for execution of works beyond the lifetime of the government. Set a schedule that needs to be reasonable but aggressive. It needs to be frozen at an early stage to prevent slippage. Too often, projects, once they get started, get new people involved who have new opinions and want changes in the design. This always causes delays. Late inputs to the design and execution should be ignored unless they are critical. In other words, if there's a fault there which is preventing the project running properly. A perfect solution is not necessary. There's an old proverb that states, perfect is the enemy of good. The government must enact laws to limit objections. Too many infrastructure projects are delayed by individuals and special interest groups' objections. The public good must take priority. We also should consider renationalisation of power generation and distribution to prevent the need to make a profit being the deciding factor. So the next steps, government must execute the plans, identify the big users. This is a topic for another presentation, but one example is we have many process plants in Ireland that's pharmaceutical, chemical, food. They use big quantities of oil and gas for steam raising, etc. For instance, the Diageo Guinness brewery in Dublin uses as much energy as 50,000 homes do for space heating. It's much easier to track one bigger site for conversion to renewables rather than 50,000 homes. This, I think, speaks for itself. I don't think it needs any further comment. As I said, we have an Everest to climb, and we are only in the foothills. We have just 20% of the work done and a further 80% to go. Thank you very much for listening.
Thank you, Brendan. Really appreciated the presentation there. Much appreciated and very insightful.